So there's different ways that we can determine what things are function and non-function. The first one is an ordered pair. So I'm actually going to go over here for a second. Now, ordered pairs are when you have an x and a y value, okay? You know you have a function when your x's, so your -2 here, your 0, your 3, and your 3 do not repeat. I'm hoping you recognize that automatically, okay? Our 3 is repeating here, which means we actually don't have a function here. The only reason why you would have a function is if it was all different numbers, okay? So for instance here, if I had -2, 0, and then I had, I don't know, 3, 9, and then I had 4, 5. That would be a function. This ordered pair here would be a function because none of our x's repeat. We have a -2, a 3, and a 4, but it never repeats. Now, if I had something where it was -2, 0, and then -2, 9, and then -2, 5, that would not be a function because we're literally repeating all of our x's multiple times. -2, -2, -2. Not a function. My last example I'll give you is, let's say we have -2, 0, and then we have 3, 0, and then we have 4, 0. A lot of my students always think that this is not a function as well because our y's are not repeating. However, I don't care if your y's repeat. Our y's can repeat. It's just our x's that we're looking at to determine on if we have a function or not. So because our zeros are repeating, our y's, we still do have a function here. Okay, so I'm hoping you can determine the difference between that. Our next piece here that we have is an equation. So we can look at an equation to determine on if we have a function or not. We will always, majority of the time, have a function if your y and your x stand alone in an equation, which means if they don't have an exponent, or if they don't have an exponent, you do have a function. I'm going to say that again. If they don't have an exponent, you do have a function. Exponents, if you remember correctly, are those little tiny numbers that go up here. Okay, so if you have something like, let me show you, 2, oh, that's big, sorry, to the little number that goes on top there. Okay, let me lower my font here. Okay, so for instance, if you have something where it's a 2 to the power of 2, that's an exponent. If your variables, so if your y has an exponent, that would not be a function. If they stand on their own, it would be a function, okay? Last one is verbal right, the relation between students in your school and each student's birthday. Okay, so the students in your school and each student's birthday. Well, that actually would not be a function because it is a possibility for, I'm sorry, this would be a function because there's no two students who are the exact same, right? So every student's their own little individual, so therefore they're all going to have their own birthdays. Some students might have the same birthday, but there are no clones of people, which means every student would have their own individual birthday. They're not going to have multiple clones of someone. I'm not going to have multiple of me in a school. Okay, so this would be a function here. You could also have mapping, right? So again, mapping is when you're looking at your x and your y values. It's just a different way to write domain and range. Okay, so as long as your x and y values are mapped out like this, as long as your numbers that are having the arrows point out of them, so like we have a 1, 4, and a 2, if they only have one arrow coming out of them, you have a function. So like 1 has one arrow. Great, so far we have a function. But if we look at 4 here, 4 has 1, 2 arrows coming out of that number, which means you're technically looking at this right now. You're technically looking at the point 4, 5, and then the point 4, -5. Well, again, we don't want our x's to repeat, and when you have 2 arrows coming out of a mapping situation on that left side for the x, it's not a function. 2 would work still, but again, since we have 2 arrows coming out of 4, we can kind of just stop and say, nope, not a function. Graphs here, right? We can look at a graph and determine on if it's a function, and we call this our vertical line test. I'll talk about what a vertical line test is, but if you can kind of draw a line, actually, yeah, draw a line left to right, and you can draw a line, you're only going to hit one part of the graph at